The pictures you see here are some PowerPoint pictures. You know, don't mistake those for brains or clouds. They're supposed to be a cartoon of consciousness. Notice that you have two consciousnesses there that are trying to communicate with each other. We have consciousness one, and it's defined by information one, and the information, as you see, is a function of experience. So information comes from experience. And the same over here with this consciousness two. Now these two consciousnesses are trying to communicate. And the concept they're trying to communicate is this pointy star. And you see, how can they communicate? They send data. Okay, now if you send data, this one you notice doesn't get such a pointy star. Now why is that? That's because all this consciousness can send is a descriptive language, symbol, metaphor, the concept of star. If this consciousness doesn't have a concept of star, it won't get anything. Or maybe it'll get a cube or a circle or something else. So you see, this one can only send what comes from its experience, the metaphors and symbols that it has in its own experience set. This one can only receive those metaphors and those symbols that are in its experience set. Now, what two consciousnesses have a duplicate experience set? None. You see? So we see there's a very fundamental problem in communications between consciousness. All you can move is data, but yet the meaning isn't in the data. The meaning is in the symbols and the metaphors by which you interpret the data. Okay? That's why it's so difficult for us to understand each other when we talk, right? It's the same sort of thing. We have miscommunications. Somebody's metaphors and symbols don't match to the listener's, metaphors and symbols. The significance of this is that reality must be a first-hand experience. Okay? Information is both the source and the result of the experience. The experience is just processed information, and that creates content. Content defines the being. That's what you are. Your content, all your information. There is no objective reality. All reality is personal. Okay? The reality you find out there is personal because it all has to be interpreted by your own metaphors and your own symbols that are a function of your own personal experience. We're going to move now from the days of Einstein back in the early 20s up to a more contemporary picture. And I like to pick these three. There's a whole bunch of other people I could pick besides these three, but I like these because they span decades. We start with Fredkin in 1992. Edward Fredkin started with a paper that was then called Finite Nature and a second one called A New Cosmogony, the digital physics movement. Edward Fredkin came to the conclusion, studying information theory and physics, that this reality is just information. And from there, he said this reality is computed and that this reality is a simulation. It's digital. Time and space are digital. I mentioned Edward Fredkin earlier. So that is back in 1992. As soon as you say that your reality is a simulation, the very first question that pops into your mind is, well, who's doing the programming? Of course, that question was put to Dr. Fredkin, well, where's the computer? Who's the programmer? He said he didn't know. His science didn't tell him that. His science told him that indeed reality was digital and informational, that it had to be, but it didn't tell him where it was coming from, because a simulation cannot compute itself. Right? Again, you have a cause and effect. The effect cannot be its own cause. He described it as other. That was his word. And he put quotes around it as well. It's in other. Well, if it's not physical, then by our simple definition, if it's not in this universe, it can't be because this is the simulation and the simulation can't compute itself, then it's not physical. So that's a source, again, from the non-physical, just like the Big Bang had to have a source from the non-physical. We seem to keep getting there in science. Okay, next, about a decade later, came Nick Bostrom. Nick has a degree in both physics and in philosophy. Now he is the head of a department or chairman of a department at Oxford. So not a lightweight scientist. He wrote a paper called Are You Living in a Computer Simulation? And the result of his study led him to say that it was highly likely, it was highly probable, he spoke in terms of probability, that we are indeed living in a computer simulation. Okay, and then about another 10 years after that, we get to Brian Whitworth. And Brian Whitworth is not a physicist, he's a mathematician. And he specializes in digital science. And what Brian did is he looked at the two fundamental ideas of where reality comes from. One of them was the standard version of it just kind of came out of nothing with the Big Bang. It's just here because it's here. The other one is the digital physics' idea that it's computed. So he said, all right, let's just make a big matrix. Down this left column of the matrix, we're going to have all of the things we know, all the facts, all the physics, all the results of experiments. In the next column, we're going to see how digital physics explains those facts. And then in the next column, we're going to see how well physics explains those facts. So he just wanted to do a comparison between the two worldviews. And when he was done, his last paragraph basically said, physicists, you need to wake up. Digital physics gives a much better explanation of the facts that we know. It solves more problems with fewer issues. So now that was just like 2 years ago he came out with that paper. Since then he's come out with another paper that basically takes the idea a little farther. So you're beginning to see that physics and scientists are beginning to take this idea that we live in a computed reality more and more seriously as time goes by. It's kind of an idea that's growing. The reason it's growing is that it makes sense. It actually does a better job of explaining the physics. So that brings us up to today. Basically, this is where honest science takes you. It's the same problem Einstein had, though. They're right up to the same place where Einstein was, and now they hit the wall. You know, Fredkin says, don't know, that's a wall. Can't go there. But breakthrough always comes from the edge, comes from the fringe. Stability and infrastructure are provided by the center. Hardly anything in science or really any other field of breakthrough comes from the center. The center's infrastructure, support. The center is funding. The center is stability. And it's good, we need that center. But breakthrough comes from the fringe, always, just by definition. Okay, reality is information. That's what we're going to talk about next. Consciousness is the fundamental reality. The larger consciousness system is a digital information system. At the most fundamental level, consciousness is information. Okay. Information at the most fundamental level is bits. And bits at the most fundamental level are ones and zeros, offs and ons, just a binary state. Now, we'll try to make that a little more reasonable to you. Think of the reality that we have around us right now. Okay, you're in this room, you're listening to me talk. What makes your reality? You're getting light, you're getting sound. That light and that sound turns into digital information, does it not? The light hits your eye, gets focused to the retina, and after that, it's electrical impulses. Little blips, not continuous pulses, but discrete electrical impulses. Take those impulses a little further, and what do you get? You get neurons, patterns of neurons, little discrete pieces of information. Information in the pattern, in the neuron, in their sequencing. So that's what this reality is, and the same with the ear, of course. It gets turned into electrical signals. So now imagine that you didn't have any senses. You were put in an isolation chamber down in the bottom of a dark hole someplace. Okay, no light, no gravity, nothing. You're just in this hole. You have no senses whatsoever. And let's say that I could feed your nervous system the same electrical signals. What would you experience? You'd experience this. There's no difference. Your reality is really those little electrical signals and the neurons. That's what creates this. So the idea that your reality is information, you see, is not that big a stretch. It's just digital information. Now you take all that information, you take those signals, those electrical impulses, those patterns of neurons, and you interpret them. And this is what you get when you interpret them. Now, how do you interpret them? Well, you started to learn how to interpret them the day you were born. That's what an infant is doing. You know, an infant's lying there and it sees its hand and it doesn't even know that that's its hand. There's just something there and they haven't figured out yet that they can control it. And they are learning how to interpret that data. That's what they're doing. So as they experience things, their eyes begin to focus, they see things, they have to interpret. What does that mean? How do I interact with it? And eventually they build up a set of algorithms, if you will. They build up experience how to interpret all that data they're getting. All those little electrical impulses and all those patterns of neurons mean something. Okay, so that's how we learn to interpret that data. So now it doesn't seem to be that big a step if we say, all right, we're consciousness. We're just a non-physical consciousness, and we're getting a data stream. We interpret that data stream to be this reality. Okay, so we see how we've taken just a couple of steps in that direction to try to make this make sense for you. Okay, so information is both non-physical and it's subjective. Thus, consciousness is non-physical and subjective. Okay, I'll have to explain a little bit why information is non-physical, because we think information is physical. That's because we confuse information with code symbols and with the media. For the information is, let's say, the paper. Let's talk about a book. Okay, the paper is the medium. The ink letters on the paper are the code symbols, but that's not information. That allows us to store and to transmit information, but it's not information. Information is the meaning, the content, the significance. That's the information. Okay? And that requires a consciousness, because that has to be interpreted, you see. Your computer, we call it an information processor, but it's not really an information processor. Again, that's just word confusion. It's a symbol processor. It processes ones and zeros, is what it processes. It processes our symbols. The information doesn't occur until somebody reads those symbols. That's an important distinction to make. Okay, so that means understanding is always subjective. Your reality is really subjective. It's your interpretation of the data. Everybody's walking around in their own personal reality. But this is a multiplayer game, so we have other people that we interact with. Okay. Now, we'll talk just a little bit about information systems and evolution. Okay, information in a digital system is represented by organized bits. Information systems have entropy. The word entropy and the word organized are a matched set. Okay. The word entropy is a physics term that is a measure of disorganization. So where you have high entropy, you have a lot of disorganization. As you lower entropy, you have more organization. Okay, now you can imagine information has to be organized, doesn't it? If you just have a lot of random letters of the alphabet thrown together, you don't have information. You have to organize them in just the right way, and you get information. I'll tell you a little bit more about entropy. Entropy has two fundamental aspects to it. One of them we just talked about, and that's order, whether things are organized or not. The other is that when they're ordered, you also, not only do you have lower entropy, of course, but you get more power. Things work. Things can affect other things. Now, that's not as clear with information as it is with other things. Take a bottle of gasoline. A bottle of gasoline is very highly ordered. All the little molecules of that gasoline, and we'll call the gasoline the system. All the molecules of that gasoline are ordered. They're very closely packed together. That's what makes a liquid. Okay, and that gasoline in that ordered state can have a lot of effects, right? It has power. It can make your car go. It can, throw a match in it and it can blow things up. It's got an ability to change things. Now let that system gain entropy. We do that by just taking the cork out of the bottle, letting it evaporate. Okay, now our system still has the same number of gas molecules in it. It's just that they're all spread out through the atmosphere. They're random now. They're not ordered tightly. Now what can the gasoline do? Nothing. See, it's lost its ability to have an effect. So that's the sense of entropy. It has two aspects to it. When things are ordered, they have an ability to affect, to change. They have power. They can do things. When it's randomness, randomness has no capability. Randomness can't affect. It just is random. There's no information in it. It has nothing that it can affect. Okay. So that's the concept of entropy. Now, information systems then have entropy. The more information you have and the less randomness, the less entropy they have. Now in double E terms, and I have to tell you that's electrical engineering. I said double E the other day, and some people didn't know what double E was, but double E is electrical engineering. In electrical engineering terms, we talk about signal and noise, you see. So this is the same sort of thing. The information is the signal. The noise is the randomness. Still energy in that noise. It's just random, has no signal, has no meaning, has no power. Self-changing systems with a purpose evolve to be more successful. Within their environments, they have to either evolve, stay the same, or de-evolve. Those are the only three possibilities, and only two of those possibilities are stable. Staying the same is not stable over a long term. Eventually, you either evolve or you de-evolve. Now, we're talking about large, complex systems. Okay, now, a system may, for a while, gain a little, lose a little, gain a little, and kind of stay the same on the average, but that is not long-term stable. Eventually, that either evolves or de-evolves. It's hard to keep a large system stable for a long period of time if you're not going one direction or the other. They evolve, it should make sense to you now, they evolve by lowering their entropy, right? An information system, it gets more information, more content, requires more organization. So consciousness is a self-aware, self-modifying system evolving toward lower entropy states. That's the model. Remember, this is a model. I talked yesterday about don't confuse the model of reality with reality. This is a model of reality. So this is the model that we're doing. Maybe another example about entropy. If you took a bunch of children's blocks and you just randomly threw them on the floor, they would have very high entropy and they wouldn't tell you anything. If you ordered them, if they're ABC blocks, you could spell something with them. That would be also lower entropy. But it's not just words and language. The point I want to make with this example, if you took those blocks and you put one down, one up, one down, one up, what would the next one be? Down, right? It's a pattern. So patterns contain information. How did you know that the next one would be down? Well, you saw the pattern. So the pattern itself contains information. So you don't have to spell things to lower entropy, just patterns. Anything that has structure to it, okay, is organized. If it wasn't random, it wouldn't have structure, right? Okay. Attributes of consciousness. So where we've come with our model now is that consciousness is a real, finite, large, complex, self-modifying information system where stasis is unstable. You either evolve or de-evolve. Some of you maybe will trip on that real and finite, but all systems that are real have to be finite. Infinite is just an idea. Infinite doesn't exist. You know, in mathematics we talk about infinity, but you can't ever get to infinity. It's just a pretend point that you get close to, but you can't ever get there. It doesn't exist as a real thing. Okay? It's just a conceptualization. So no real system can be infinite. Infinite systems would require infinite energy and infinite time to assemble infinite stuff. You see, it all breaks down. It's not logical. Infinite isn't real. It's just an idea. So this system, this larger consciousness system, is finite because it's real. It's complex, self-modifying. Individual consciousness, or the larger consciousness, consciousness in general, evolves toward lower entropy, higher quality, more spiritual states. Now that's kind of taking a jump there. I'm going to equate lower entropy with love, with spirituality. Okay, now how does that work? Well, just think, what is consciousness? Consciousness is really a group of individual awarenesses. And we're going to get to this individuation part in just a minute. But think of consciousness, or just imagine a group of consciousnesses. Okay, so now you have this whole group of individuals. And this group is going to interact. That's what consciousness does. It exchanges data. It interacts. You know, that's an information system. All it can do is trade information. So it's very interactive. Now let's talk about the two extremes. Here's one group, and we'll call that group utopia. Everyone in that group is loving, caring. It's all about other. They're mutually supportive. They're cooperative. They're trusting. They help each other. The whole takes precedence over the individual. Okay, everyone looks out for everyone else. Now that's one group of consciousness. Do you see? That's a very constructive group, right? That group will build. That group will multiply and grow and build things. You know, somebody's barn burns down, right? All the rest of them come over and help them build it back up again. That's a very constructive, supportive kind of a association. The other one, instead of utopia, let's call that hell. Everyone's full of fear, full of ego. It's about the self. It's a me first. Everyone else has to fend for themselves. Me at the expense of others, self-centered, no trust. Why help or cooperate? What's in it for me? Very competitive. You destroy, debilitate, eliminate your competition, trick, manipulate, control, dominate, use others, right? Now that's not a building, growing, helping each other. That is a high entropy system, isn't it? You build something up, somebody else comes and takes it away from you or tears it down just because they don't have it, so they don't want you to have it either. You know, it's that kind of a thing. So that's a very destructive. It's very difficult for entropy to decrease in that kind of an environment. So now we look at these two environments. One of them is low entropy, very supportive. The other one's high entropy, very destructive. And you can see love is the direction that low entropy consciousness moves in. So when you have a consciousness system full of individuated units of consciousness, the way it evolves is to lower its entropy, become more organized, more productive, more powerful, and the way you do that is by moving toward love, by caring, by having positive associations, by cooperating, by helping. The opposite, hell, sounds more like here, doesn't it? Kind of sounds where we live. Low entropy, evolution, consciousness evolves, it's an information system, it evolves towards states of lower entropy. That's states of higher cooperation. That's states of giving, caring, helping. So the entropy system, or the consciousness system, is evolving toward love. Once we have that idea, that tells us a whole lot about the system we're in, what we're doing, and our purpose and our point. But let's go on a little bit with the attributes of consciousness before we get to that. Okay, what constitutes consciousness? There's just a few things, 5 things here that I have listed. You have to have input. Input defines experience. Right? You need data coming in. Memory. If you don't have memory, every experience is your first. You can't learn anything. There's no cumulative growth. You need processing, so you can tell whether where you were is better or worse than where you think you're going or where you're trying to get to. Otherwise, you have no direction. And you have to have purpose, which then defines that direction. And you have to be self-modifying, okay, self-improving. You have to be able to change. You go back up to the first one, input. You have to back to go and change the input, change the processing in order to optimize the system. Input, memory, processing, purpose, self-modifying, self-improving. Now, what does that sound like? Well, that sounds like life, doesn't it? Isn't that kind of the definition of life? Think of the first biological cells. Okay, we're back in the primordial sea. We've got just maybe a little clump of maybe 1 or 2 or 3 celled things. Well, what did they have to have in order to evolve? They had to have data. They had to have some connection to their environment where they were getting information from the environment. They had to have some sort of memory, At that point, it obviously wasn't intellectual, it was a cellular memory, processing, some way that they could determine whether they were better off or worse off for the random mutations they were taking. They needed a purpose, which their purpose, of course, is to survive and to procreate. And both the survival and procreate in a physical system can equate back to lowering entropy, more organized, more capable, more effective in your environment, you see. And they had to be self-modifying. Obviously, if they weren't self-modifying, they'd still be just 2 or 3 celled creatures and, we wouldn't be here. So it has to be able to change itself. So these are the same attributes I'm giving you of consciousness, are the exact same attributes of anything that lives. That's kind of biology. That's the attributes of something that's alive. Well, consciousness is alive. So then that gets back, of course, to the question of where did that first consciousness come from, right? Now we have the same issue in biology. Where did that first cell come from? And the biological answer to that is, well, you had the right amino acids that just happened to be in the right place in the right environmental conditions that were just friendly enough but still challenging. And, they somehow got together and made a cell. So, in other words, we don't know. Okay? But we're guessing. There wasn't anybody there. There was no reporter on the spot, with a microphone interviewing the first cell. So we have to guess at what happened there. And of course, it's the same thing with consciousness. So we take the same line of thinking with consciousness. So you need to see yourself, your body, of course, is a community of cells, right? You're a community of a few billion cells that make up your body, okay? Are they mutually supportive or are they mutually destructive? Well, they have to be mutually supportive, right? Otherwise, you wouldn't last long, okay? So that's a system that works. You see, mutually destructive doesn't stand very long. Consciousness is also a community of cells. And you and all of you are cells. You're part of this larger consciousness system. And you need to be a cooperative part or the system won't stand very long. Okay? All right. So this origin of consciousness, we say the same thing that the biologists do about the origin of the first cells, and that is that there was this primordial potential energy that existed that could discern one state from another. And that may have taken who knows how long, but eventually it got to the point that it could say, all right, I noticed that there's a this way and a that way. Just 2 states that it was aware of. Now what does that tell you? Right away that tells you there must be time, because you have a before and an after. This way and that way means, you have to have some sort of fundamental time in this consciousness, some sense of change. Time comes from a sense of change. If you can sense change, then you've just defined time. So we get that, and then we say that, well, just like the cells found out that more was better, right? They could divide, multiply, and then they specialized, so they had special organs and other things that the individual entities became more complex. Well, more complex, what that means? More ordered, right? Lower entropy, more capable, more power. Okay, and consciousness did the same thing. It divided, it became more complex. Instead of just this or that, or this way or that way, there was a this way, that way, the other way, and some other way, you see, or this, and that. Well, now what are we doing? We're producing binary 1s and 0s, aren't we? This and that's just a 1 and a 0. So if you can duplicate that and have a whole bunch of 1s and 0s, thises and that's all you need to start building memory, processing. See, all the rest of that stuff just comes right along. Purpose is to lower your entropy. Self-modifying, well, yes, you'd have that or it wouldn't have started in the first place. So we can kind of go back and guess at the origins of this consciousness system if we start with that one assumption of a primordial potential energy that could differentiate one state from another. That's basically all it takes as an assumption, and that's assumption number 1, that exists. And of course, nobody was there to interview that consciousness, on the spot either. So this is just a the same way the biologists do. It makes sense because we're here, right? And we're conscious. So we kind of go back and say, well, if so, then how could it have started? And we use that same pattern. We get to the point that then we say, well, where did that potential energy come from, right? Because we want to keep knowing what came before that. Where did that come from? Well, there are limits to your knowledge. We get to a point where we can't answer those kinds of questions. And logic will tell us why that is. Here's a little cartoon that I like to use to explain the limits of knowledge. Another PowerPoint wonder, right? So here's us, this little red spot in the middle. That's our universe. That's our entire universe, is this little red spot. Okay, and then that makes this kind of lake around us. Okay, that's basically what I call our system. That's the physical universe and all of the stuff that's non-physical or outside of that universe that affects us, like whatever created the Big Bang. You see, it's all that stuff that's out there that's not in our physical universe that affects us. And everything past that out in here doesn't affect us. That's just the stuff that interacts with us. So what is this? This thing looks like a lake out here. Well, that's the larger consciousness system. Okay, that's this larger consciousness system we're talking about. Well, now out here, what's this? That's beyond the larger consciousness system. And we just can't get there because we're consciousness. The only way to see this system as an objective system is to get outside of this larger consciousness system. You have to get into this before you can look back and see what's the next level down, you see? That's just logic. That's the super system. This is now the super system, and these are subsystems. A subsystem cannot define a super system. It doesn't have what it takes. You have to get out into that super system, then you can see the subsystem. But you can't do anything more than just explore the subsystem you're in. Now, we're consciousness, so we can get out of that little red dot. That's our physical universe. We can get out into the larger consciousness system. We can even get out into this whole thing. We can get out through all these levels because we're consciousness. But that's as far as it goes. So these things that are out here, which is where did that potential energy come from in the first place, is just an unknown. We can't get there. Now here's an example that'll make that more intuitive. Let's say that this universe now is a bacterium in our intestine. Okay? Just a bacterium in our intestine. That would then make this next level out the GI tract. Okay? It's our whole gastrointestinal tract. Now, if this bacterium was a brilliant bacterium, had an IQ of 200 plus, really did good science, what could it know about these levels as it goes out? Now, you see, it can't get outside of that GI tract. Mostly, it can't even get outside of the piece of intestine that it's in. It's kind of stuck there, but let's say it's smart and it passes the word around, up and down the GI tract, and they talk, they have a good language, they do good science in there. What can they tell about these outside levels? Well, they may be able to get from one end to the other to that GI tract, but that's about it. So what's this level then out here, the larger conscious system? That would be like the body, right? They're a part of this body. That'd be like our skin and our toenails and fingernails. So what did these intestinal bacteria know about fingernails and toenails and hair and skin? What could they know? Nothing, you see. But, well, maybe cells, if they could communicate or something. But now let's take one more step and get out into here. What would this be? Well, that would be the food industry. That would be chickens and cows and pigs and corn and rain and sunshine and nuclear fusion in the sun to make sunshine. That would be all of that sort of thing, grass and plants, trucks, refrigerators, grocery stores, all of that. Now, what can these intestinal bacteria know about grocery stores and tractor trailers and rain and sunshine? See, nothing. They can't. It's outside of their reality frame. It's too many levels out. They can't get out there. There's no way for those intestinal bacteria to understand rain and germination of seeds, you see? So that's the same state we're in. So we say, well, where did that potential come from? And the answer is, I don't know, because that's too far for us to look. We can't see that far upstream. And it's not something, that doesn't mean that the theory then is flawed because it can't determine its cause. It just means that you're stuck at that point because you don't have vision past a certain point. Now, my son, he read this my books when he was 17, partly on his own because he was very interested, and partly because I twisted his arm. He was homeschooled, so I made that part of the curriculum. And this is the one thing that kind of stuck with him more than anything else. And at 17, he was really disappointed when he came to this discussion, only like a teenager could be. Not only did he find out that he didn't know everything, but that he couldn't know everything. And that was very disappointing. But we have to accept that. But an observation that I'll share with you is that the smaller your reality, the more convinced you are that you know everything. And that's true whether you're a philosopher, a theologian, or a physicist. Typically, being able to see a substantially bigger picture at a fundamental level produces great leaps forward in knowledge and ability. So if you can get out another level and look back, suddenly everything becomes simpler, understanding gels, it's a big aha moment. Look at the times in our history when that's happened. We went from flat earth to round earth. Suddenly there were no more dragons out at the end where you fall off, the flat earth. A lot of fear abated, trade, commerce, sharing, ideas, concepts, cultures melded. I mean, the whole, look what followed. Look what followed as far as civilization and commerce. A great expansion of knowledge. We found out the same thing with Newtonian physics. One time we found out that we had gravity. Newton said gravity, sun's at the center, everything goes around it. Suddenly the whole universe started to make sense. Instead of these funny patterns that repeated, but we had no idea why, we could understand all that. We started to see ourselves as a part of the universe. And that Newtonian physics then led to what? It led to the Industrial Revolution. So when you get these bigger picture looks, it makes a big difference downstream. All the science, that's basically been our modern science, started from there. Another explosion of knowledge, civilization, and technology. Well, today and tomorrow, we're going to peel back one more layer. We're going to move our understanding from limited concept of objective, deterministic physical reality to the larger, more general, powerful concept of reality as an evolving digital consciousness system. And there will eventually be an explosion of knowledge, civilization, and technology. That will come. And even when we get there, we are still going to have to realize that there are limits to our knowledge. There are things we just don't know. Okay, 2 assumptions then. I've been over both of them, so we just make them formal here. One of them is assumption 1 is a potential energy form, call it primordial consciousness, exists. It's a medium capable of self-modification. Okay, so basically what we're saying is the potential for consciousness exists. Okay, now justification for that is we're here and we're conscious. That's not a big leap. Second assumption is that in systems with many complex potential outcomes, evolution directs and encourages change toward more profitable states of being. So if it's a self-changing system, like we are, then you evolve. Okay, so those are the only 2 assumptions that are really in this theory. Everything else is a logical derivative from that. Now, assumption 1 does not represent a weakness. It's not like that's kind of soft science. It's absolutely required. Any big toe without at least one assumption that falls beyond its own causality is doomed to fail. If all your assumptions are inside the subset, you're never going to define the superset. And that one assumption that says consciousness exists, that's the one assumption that takes us out of the box. It exists as a superset to us. All right, so I'm going to run through some of these summary things just to kind of help it gel in your mind from yesterday and today. Here's what we've got so far. Consciousness is best modeled as a superset, a self-modifying digital information system capable of computing virtual realities. Okay? It's kind of where we've come to so far. The larger consciousness system evolves by lowering entropy of its system. It lowers entropy of its system by organizing the bits into a more profitable configuration. Feedback of the results of previous choice allow us to modify future choice. Okay, actually, that feedback allows us to modify the intent that drives future choice. So that's us pulling ourselves up by our bootstraps to evolve a higher quality of consciousness. Okay, now 2 slides. First one we're going to say, where do we come from? We, individual consciousness that we identify as ourselves. And the second we'll say, where does this reality come from? So we want to justify both of those, not just state them as facts, but justify them logically. Because experience is the generator of input, right? You have to have input. That's one of the things you have to evolve, to be alive, if you will. Experience generates input. Okay, consciousness then facilitates its own evolution by creating many smaller units of consciousness and setting them loose to evolve. That is, to lower their entropy by interacting with free will. Okay, now why would that be a good idea? Well, otherwise, all of the experience that's required to lower entropy, and right, this consciousness system now has the 2 choices. It can evolve or de-evolve. It can evolve or die, long term. So it needs to evolve, and it needs input. It needs experience. Well, you know, those cells had an environment to deal with. What does this consciousness system have? We just said the limits of knowledge. We don't know what's outside of it. We know it's finite, but what's outside of it's past our knowledge. So we don't know what, if anything's out there. So the only thing it could interact with was itself. Right? So it could only interact with itself. That was its limit of input. That's a very limiting input. So just like those cells did, it divides. It needs to lower entropy. So it divides. It needs to become more complex, more ordered. So as it divides, it creates 2 chunks of consciousness that can now communicate with each other. Consciousness and free will go together as a matched logical set. You cannot have consciousness without free will. You cannot have free will without consciousness. One requires the other. Okay? They're a logical set, like front, like heads and tails of a coin. They must go together. So you have consciousness dividing into smaller units because that creates novelty. That creates experience. That creates things that are unexpected. Because now you have things interacting with yourself. Well, then you keep doing that a few more, billion times or however many you want, and you have lots of consciousness. You have now whole communities of consciousness, and these consciousness can interact with each other. They can form their own groups. They're sharing data, right? Now, just think of the novelty you have. Just think of all the opportunities there are to take that data and learn how to reduce the entropy of it. Make it meaningful. Make it mean something. Evolve. So that's where we come from. We are part of the larger consciousness system strategy to evolve. Evolve or die. It evolves. We're part of the strategy. Break yourself into pieces. One cell isn't very efficient. Many cells can do a whole lot more. Okay? We saw that in biology. Okay, so now that tells us a lot about purpose. What is our purpose? Our purpose is to lower our entropy. Right? We're little chunks of consciousness. We're supposed to lower our entropy. And what does that mean? Well, we already got that. That means grow toward love, compassion, caring, being helpful. That's where it takes you. That's the positive direction of evolution. So now we know what's positive and versus negative, good versus bad, right? Moral versus immoral. Those things that are positive, good, and moral are things that lower our entropy, help us evolve. Those things that are negative, bad, immoral, help us de-evolve, higher entropy. So now we've defined love, spirituality, good and bad, moral and immoral in terms of a scientific term like entropy. That's kind of amazing all by itself, that we've made that connection. A technical definition of love is something to behold all by itself, I think. Anyway, we can take this system then and create a moral system, an ethical system that will tell you what's moral and what's not moral as far as things to do and how to act and how to interact. It develops a moral system just out of this idea of evolution, becoming love. You're part of a consciousness system. All right. So where does the physical reality come from? That's where we come from. That justifies our existence. But we have to justify the existence of this reality where we are. Well, to produce an effective, profitable interaction, you need two things. You need a goal, purpose, and our goal, we already know, is to lower entropy. It's to find better, more efficient way to evolve. It's our purpose of any self-changing complex system. The second thing you need are constraints to provide structure. Imagine for a moment that you are in a game of anything, let's say a game of cards. Okay, there's 4 people, they're sitting around a table, they're in a game of cards, and in this particular game there are no rules. Okay, now how do you win? How do you improve your game? You know, what do you do? Obviously there's nothing. Without rules, there's no context. Without rules, there can't be any logic. There can't be any process. There can't be any way to know whether you're winning or losing. You see? Structure and rules define the context of interaction. Now we know that, of course, when we send our children to school, right? We sent our 3rd graders off to 3rd grade and there were no rules. What would they learn? You know, not much. It's the structure provides the context for their interaction, for them to learn something. So here you are, this consciousness system. You've broken yourself into lots of pieces, but there's no context for it to make any sense. You're in a game now where you're trading information, but there's no structure, there's no rules. You can see it's very hard to learn, right? How do you take that exchange of information and lower your entropy with it? How do you do something useful with that? It's very difficult. Okay, the data has no context, no continuity, no structure, which means it has no feedback, no logic, no learning. Okay, so without constraints, you end up with chaos. Evolution's difficult. So we have a rule set. We have a rule set that defines the game we're playing so that we can get some traction here and lower our entropy. What's that rule set? It's our science. Rule set. There's a rule. If you drop something, it falls down instead of up, right? That's one of our rules. You can depend on it. And because you can depend on it, you can learn to interact with it. You can build with it. You can construct. You can start building order, lowering your entropy. So here we are, individuated units of consciousness. We're living in a virtual reality. Okay, why I call it a virtual reality? Because this is a reality that was made up to give us traction, to give us some kind of coherency in our interactions with each other. Okay, it's virtual because this whole thing's computed. It's just an information system. That's all we are. Pieces, subsets, information. Okay, we have inputs, we have memory, we have processing. You know, we have all these things, right? We're self-changing. We can grow and evolve. So we're these units of information, self-changing subsystems. And these virtual realities are places where we can interact profitably because there's rules and logic and therefore learning. Well, there's 2 virtual realities that we live in all the time. One of them is this one, where we are now. The other one's when we dream. When we dream, it's a different reality frame. Different rules, different physics, different causality, but we operate in it just the same. So there's 2 realities. Well, there's a whole lot more than that. This larger consciousness system doesn't depend just on us. If you're a larger consciousness system and you find a way to generate a nice reality frame like this for consciousnesses to interact in, why wouldn't you do it again and do it again? Because then you're parallel processing, right? What you're trying to do is lower the entropy of the system, and every little piece of it, you and I, we lower our entropy a little bit, the system lowers its entropy a little bit. So you duplicate and parallel process as much as you could, and indeed there are many realities out there, but they're all virtual. The only thing that's fundamental is consciousness. Everything else is virtual. All other realities are virtual. There are some, like this one, that are more constrained, more rules. They seem very physical. Well, actually, the dream world seems physical when you're in it, doesn't it? When you're dreaming, that dream world is physical. I mean, you do things there and you interact, and it's just as physical as this. Of course, when you're dreaming, this reality is non-physical. And the dream world is physical, and then vice versa. When you're not dreaming, this is physical. The dream world's non-physical. See, there is no fundamental difference between physical and non-physical. It just depends on where your focus is. Okay, there are also reality frames that are less constrained, like our dream world, like the world you get into when you do out-of-body or when you travel in a larger conscious system. That's less constrained reality frames. But that's just another virtual reality. And I've been in lots of these. There's lots of various virtual realities, and each one of them has their own physics, their own rule set, their own clock, their own time. But all the reasons at the very top level are the same, and that is evolution. All of these virtual realities are there to learn. They're schoolhouses. They're various kinds and types of schools for us to get in and learn. Okay, so how do you get around in these realities? We're going to talk a lot about that on Sunday, but basically, it just has to do with the data stream you're getting. Now we're getting this data stream. We interpret it to be this reality. You get a different data stream, you get a different reality. So you just need to switch data streams. You can switch data streams just with your intent to do so. It sounds very simple. Actually, it is very simple eventually. What makes it difficult is that you have so many beliefs to overcome to allow you to do that. It's not really so hard other than you make it hard because of your beliefs. But we'll get into that on Sunday a whole lot. Okay, let's talk about virtual reality. This is always a bit of a mind bender because it runs counter to your cultural beliefs. Okay, one concept of virtual reality is that everyone gets their own personal data stream, right? It's not like there's one big data stream and we all get the same thing. Obviously, that's not the case. We all get our own reality stream. Now, I'm going to talk about some virtual reality games that you may be familiar with. There's only two of them I'm familiar with, and that one is World of Warcraft, because my son played that from probably when he was 11, and he probably is still playing it today. You know, and he's 24 now, I think. So I've seen a lot of World of Warcraft over his shoulder, and my daughter played The Sims. So those are the two that I know about, but they make very good examples because virtual reality is virtual reality, and it all works the same way. You know, we live in a fractal reality. So the fact that we're making virtual reality from a virtual reality that's part of another virtual reality, you see, that's just the fractal process, just different levels and scales, and all of reality is like that. It's all a fractal process. So in any case, look at this. Think of you're probably all familiar with this. If you've never played these games, certainly you know people who have. And if you have teenagers, you definitely know people who have. Okay, the characters and the game setting. Okay, that compares to your body in this environment, right? This is the game setting, and you're the character. Now the server that generates the set, enforces the rules, defines the characters and the characters' interactions, serves as the interaction between the characters and players. That's the larger consciousness system, right? That's the server. You're starting to feel one with the server? Yeah. Now the local computer would sort of be like brain function. Now, not exactly. In this case, the analogy with World of Warcraft and Sims breaks down because the local computer really isn't where all the data for that character is stored. Why? Because if it was, they know you'd cheat. You'd find a way to change, raise your level, put more money in your bank account. So they don't let you have the data on your own computer in these virtual reality games because they don't trust you. They know you're very clever, probably cleverer than they are, and they need to keep that data so you can't meddle with it. But in this system, that's not a problem. They know you're not that clever. The local computer, that's like, okay, we'll say that's your brain function. And we're going to get into a thing later today toward the end of this day about the brain and how that and consciousness interface. But we won't do that right now. The players that have hold of the mouse and are doing all the clicking and stuff, well, that's basically you. You see that acronym there, FWAU, that's a free will awareness unit. That's basically you, the individuated local PMR consciousness. So you're the consciousness saying, player, fight, player, run, player, go this way or that way. you're making those decisions. Okay, that's the you in consciousness. Okay, now in order for consciousness to run an effective virtual reality schoolhouse, it has to keep track of where it's been and anticipate where it's going. It's just like us, right? Our life is more efficient, and we can learn more if we have a sense of our history. You can learn from history, and you also have to have some sense of where you're going and where you're headed and how you're going to get there. Okay, history is educational because we learn best by making mistakes. That's how we learn. And being aware of what happens next enables one to be prepared. It raises process efficiency. How you interact is better if you're prepared. The consciousness system then simulates or computes and you see PMR, that's physical matter reality, that's this place. And I know physical matter seems like it's redundant, but you understand that there are other what we call non-physical, and they have non-physical matter. You know, they also have matter there because there's really no difference. Anyway, it computes physical reality 1 delta t at a time. So now we're here to time, our own clock, right? So we're in the simulation, and like all dynamic simulations, they have an outer time loop. So things happen, and then the next delta t, more things happen. Next delta t, you know, you go through, I don't know if any of you are programmers, but basically you have this outer time loop, and you know, you increment time 1 delta t, and then you run through all the code, and then you go back up to the top again, you increment time 1 delta t, and you run through the code. It's that sort of thing. So we're in this simulation. It's a dynamic simulation because we move, you know, so it's dynamic means it moves in time. And there's this outer time loop. So because we want to learn and we want to keep track of the past and be able to anticipate the future, we produce these databases. And I'm going to describe them in terms of 3 databases. They're really only 2, but it's easier to understand in terms of 3. So I'll tell you 3 and then we'll coalesce them into 2. First one is the Probable Future database. That's sort of the preprocessor of the system. All possible choices and their expectation value. Okay, so now you have this reality frame, and it's full of independent units of consciousness. It's full of stuff too, right? It has a rule set called physics, biology, science. That's the rule set. And time goes by. So for this delta t, everybody does whatever they do, right? Makes choices. That's what we do as consciousness. We make choices. We have a decision space, and we get to make choices out of that decision space. Okay, so we do that. And this system anticipates what we're going to do, and it anticipates what all the stuff's going to do. So if there's a ball rolling down a hill, then it anticipates that it's going to roll a little bit further. That's easy. But here we are making choices, and it has to anticipate what we're going to do. And you might think, well, that's going to be really hard because, you know, we're not all that dependable. On the other hand, think of the database it has. It has every choice, every thought, every feeling that you've ever experienced. From the day you made your first cry and opened your eyes, everything. And it not only has that, but it has the data before that. Okay, and the lifetime before that and before that. So it knows you pretty well. Every thought, every feeling, every decision. So you're really not that hard to guess what you're going to do. But because this delta t is so small, it doesn't have to guess very far out. If you use typical quantum mechanics calculations and we'll say that the Planck length is about right and the velocity of light and so on, you come up with a time of about 10 to the minus 44 seconds. That's the size of delta t. I don't know if you realize how small that is, but that's like 35 orders of magnitude smaller than the smallest thing that we can measure. We measure things in terms of nanoseconds, and we feel pretty good about that. That's hard to do, to get down into nanoseconds, sometimes maybe even tenths of nanoseconds if we're really, really clever. This is a nanosecond. See, this is, you're basically many orders of magnitude smaller. So that's not really that hard to guess what you're going to do 10 to the minus 44 seconds from now, you see. That's a shoo-in, right? But what you do then is you say, well, let's assume that that guess was right. Then what would the next delta t bring? Assume that's right. What would the next delta t bring? So you can do that out as far as you like. There's no limit to how far you can go with that. Now, there is a limit on how far you might want to go with that, and we know that the further out you go, the rattier it gets because you have all these assumptions, one based on the next, on the next, on the next. You make an error someplace, and that error propagates through the whole system. But once you've calculated it one time, you don't have to recalculate everything over and over again. All you have to do is follow the changes. So you've got this system, and somebody exercises that free will to do something really strange that the system didn't think would happen. Well, it's got to go in and then progress that out. But that's all. Everything else kind of taking care of itself. So you see the crunch now is much, much less because you have this future probable database. You only have to keep up with changes. You don't have to recompute everything all the time. Now, you're also going to find out it's important for another reason. If our reality is just probability, like we said, well, where do the probabilities come from? What's the probability when we make a measurement? We make a measurement and you know, we get what's probable. Well, how do we know what's probable if we haven't computed what's probable? So we need this database as part of the fundamental generation of this reality frame. Okay, that's how the reality frame works. So it requires that. Otherwise, we wouldn't have that collapse of the wave function, you know, to a physical particle from probability. So it has to start with probability. That probability lies in the future because the measurement has to be in the present. Right? That's the only place you can measure something is in the present. That's where we live. We live in the moment, in the present. Okay, now after the present, so you have everything that could possibly happen, all the possibilities of everything that could happen, every decision you could make, everything you could do, and a probability attached to that of whether or not you will likely do it, and how all the interactions will go, and so on. So that's sitting out there. That's the probable future database. You have the present moment. That's where we make our decisions. Then after that, you have this big historical database. And I break that into two pieces. One of them is all the things that we did. You know, we made our decisions, we made our choices, the ball rolled a little further down the hill, you know, whatever went on, that's our history thread. Now, everything that's not our history thread goes into the database called everything we could have done, but didn't. Right? That's everything else. That's really just one big history database with a thread running through it, which is the actual things that we did. That's why we call that the history thread. So you have this future and you have this history. And one is just the kind of the flip of the other, right? Because you have all this probability. You get that same probability now associated with everything that could have happened, but didn't, and with what did happen. Now, those databases are available for you. In the Hindu tradition, those are called the Akashic records. You know, it's just data that's there in these databases, and both databases are required in order to generate this system. Let's go on. I've got some cartoons that will let you see this, maybe a little more intuitively, because the words tend to be kind of airy and hard to grasp. Here's our system. Remember, that is our physical universe and everything that we call non-physical, outside of our universe, that interacts with us. This is kind of a state vector approach for those of you into math, physics, or engineering. So here's our system, and it has just three choices. It can go to here, to here, to here. Now, of course, it probably has trillions of choices, but we're just going to talk about three because trillions are too hard to draw in PowerPoint. So I just did three, but the thing is, the idea is the same. So it makes a choice. Well, before it makes the choice, all of these are the probable future, right? All of these things it could move to. These are all states. All these, this, and this are three probable future states. So it makes a choice and it moves to this one. Now, at that point, all of these are probable future states. These just fell into the past, right? These are the things that we could have done but didn't. Okay, that's the unactualized history database. This now is our history thread. Now we make another choice. We could go any one of these three blue ones. Those are our choices. We choose this one. When we choose this one, all of this stuff falls into the stuff that we could have done but didn't. And now just this becomes our future probability, right? These are the states we could get into. And then we make this choice. We could have gone here, here, or here. And we could take this one. At that point, everything except for this goes into our history. Everything that we could have done but didn't do. So that's just a little visual that maybe helps you see what it was that I just said. Okay. All right, we'll go into the next one. And here's another visual that will help you understand time a little better. Time is 0. That's the present moment right at the origin. And then time goes out in all these directions. Time goes out in a radial from the center. So think of this as a surface, and these peaks are probability functions. Probability of something happening. So this probability, this is the future probability database, if you will, and I'm making a two-dimensional or a three-dimensional picture out of it to give you a little intuitive sense of what I'm talking about. So the further you go out here in time, you see there's you start to get out here further in time and there's really not much that's predicted because it's too hard. But right here around the center, you have a lot of tall peaks because that's stuff that's going to happen real soon. So it's much easier to have a probability, a high probability. This probability is going up straight up off the center of this. That's the z-axis going on. I don't know if you can read that or not, but that's actually a word there that says probability. So probability is the height of these things. So right around the t equals 0, a lot of things are very probable. So as time goes on then, think of the surface as just disappearing into a hole in the center. It's like a tablecloth on a round table, and it's just disappearing down a hole in the center, okay? Because the present moment is right there. This is a future probability survey. Okay, so that's the idea. Now what you'll see is that sometimes you'll have things like this one or like this that are kind of far out, but pretty probable, pretty high probabilities. Okay, that would make a very good guess, a good prognostication if you knew about that. Sometimes you have things like that, well, there's something going to happen out about there, but we don't know whether it's this, 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 or this. It kind of spread out. We don't really know. There's uncertainty about it. It's not a sharp peak. It's kind of spread out, and some of them are spread out in time because we don't know exactly when, and some of them are spread out this way. We don't know exactly what, and others are pretty sharp peaks. Just depends. So that's kind of a look at the probable future database. The cartoons sometimes help you get an intuitive sense of what we're talking about. Okay, larger reality system. I said there were a lot of virtual realities out there, and there are. There's many that are just physical, like this is physical. These can be visited. It's a matter of just switching into that data stream. We'll call those other physical realities, if you will. And then there's others that are not so physical. But all of them are teeming with life forms. All of them are evolving. They all have basically the same purpose as we do, which is to lower entropy. Evolution fills every niche it can, just like it does here. If there's some little niche somewhere that can support something, well, that something's in there, right? That's the way it works. So you have all these reality frames, and whatever can use that space, whatever can evolve there, does evolve there. So you have a much broader set of evolutionary possibilities when you have a less constrained reality frame. As the constraints get tighter and tighter, then there's fewer things that can evolve there because there's less degrees of freedom for that evolution. Okay, so we find that realities like this one that are fairly constrained are also constrained in what can evolve here. Those, like an out-of-body space or your dream space or whatever, there's more that can happen in those. So you'll find things that are, smaller and bigger and uglier and whatever there, more extremes there because you have a broader evolutionary space because you have a less constrained system. So there's lots of things there, and every niche is filled. Okay, here's the last cartoon. In my experience, I found that there are these subsets, and in the book, I label them like a mathematician would label them. Here's us. This is our subset in this circle, and I call that N division. You know, that's N, and we have all of these physical matter realities here, and I start with 1, 2, and then here's us, and there's ... K, so there's lots of those. And then there's these other things. Maybe our dream reality might be part of those, but there's lots of those things too. That's kind of your out-of-body realities in here. So this is our N division, but there's also these other units, and kind of the best way to describe those is that they are almost like they have different experimental protocols. They have different ways of organizing. In other words, it's a different approach to the schoolhouse. You know, it's like, so one of them's maybe like a public school, and the other one's more like a private school, and then there's some that are you know, have different attitudes, different experimental protocol toward providing a learning lab. So they're all just a little different. Now you can get around in those, you can move from one to the other, but mostly beings that are in one tend to stay there. And that's because you tend to learn the ropes, know what's going on, you kind of get suited for a particular evolutionary pattern. It's easier to repeat it than it is to you know, change a lot. It's the same reason why most people kind of live in the same culture most of their lives. You know, you could jump from culture to culture to culture, and every 3 years you could locate in another culture, but you'd probably, you know, not want to do that. It would be just too much. So it's the same reason people tend to stay in their particular cultures. But I just offer that because I've just noticed that seems to be the way it works. There is some cross-pollination, but in general, not a lot. Okay, next. It's a break time? Well, good news, ladies and gentlemen. You get 10 minutes. Please come back on time.